Ematicus PGAA batch. We will wait for, good afternoon. We'll wait for 3-4 minutes for everybody to join in. Okay, I'll be back soon. Just let's give some time because we'll be doing something very important today.
Sir,
Yes, welcome. I think it is 3:05. We waited for everyone. We will get started now. We have Bhupender, Jaydeep, Sarvanan, Satish, who all are with us. Welcome. Yes, Sarvanan,
sir,
please tell me.
yeah, I have a doubt, sir.
Hmm.
Let me share my screen.
Yes.
Is it visible?
Yeah.
No, sir. If you see, it's a multi-class classification problem,
Huh.
which has various labels. For example, bicycle, motorbike, cat, table, boat, and people. It all
Yes.
comes under a different folders.
Huh.
You see. Yeah, it all comes under these different folders. It has
Huh.
training set, validation, and testing set, different tests.
Yeah.
Okay, if you see, while I was working on it, I used the image generator transformation to change the image and pass it through the convolution 2D.
Huh.
While passing, my accuracy is not even increasing. Every time I add more layers, it's only keep on decreasing. I don't know. And
How many
that's what I
images?
was
How many images are there?
over 1,400, I believe.
1400 total images.
Yeah, it's okay. 240. That means okay. Over 1,400 images for the test and training, and 400 plus for 480 for validation.
Right. So, we add, go to the image generator. Let me see. Here you are doing the image generator. Go up.
No, I'll just add an. Yeah, this one.
So this we have, you put an image generator. Mm, but we are not using,
The highest.
are we using this image generator down somewhere to generate new images?
Yeah, yes, sir. We are passing the training and test path image, and it indices the images instead of converting. It's like similar to categorical to numerical, right?
Ah,
So it's converting the classes into it. If it comes under this bicycle, it's zero, boat is one, like that. It's categorizing.
right. So this problem is similar to the one which we had done earlier, cat and dogs. You see, I had
Yeah,
shared that code with you, cat and
yeah.
dogs.
That also I have faced. I also had a different issue with that, but I'll deal with it later.
Okay.
Yeah,
So
this
now,
one.
yeah,
I don't know
now
what
if you,
else to do.
now if you see the cat and dogs original image, it had almost around 50,000 images, correct?
Yeah,
If you see the original folder of the cat and dogs, it had 50,000 images only of the
yes, sir.
cats and dogs. And what we did was we took only around 2,000 images, and we were trying to build a classification model over there, correct?
Yeah,
I'm telling you the problem that is happening. Now with 2,000 images also, we were not getting good accuracy. If you see that example,
okay,
okay. So what we
right,
had to do, we had to increase the amount of images. So the
okay,
problem that we are facing here is this image of 1,000 is, or even 2,000 is very less.
okay.
Minimum, you need at least 20 to 30,000 images minimum.
Yes, sir. But is there any way to increase the accuracy?
There is no way to increase the
Because
accuracy if you have less number of images.
yes, but anything can be done with adding more number of layers over here.
No, you cannot add more number of layers. There are two things which you can do. One is you increase the number of images using the image generator. Okay,
Okay.
that is the only way. Another way,
Yeah.
if ever you have such problems where your number of images is less, you can use a technique called as transfer learning.
Okay.
The technique of transfer learning involves using pre-trained models. Okay,
Okay, sir.
pre-trained models like YOLO. You can do a Google for YOLO. YOLO, YOLO. It is a pre-trained model, which means YOLO already has thousands of such objects which are already want to do image identification, then you use those pre-trained models. That is one way. Another way is you use the transfer learning technique where your existing pre-trained models are again used and customized to meet your needs. So these are three ways in which you can achieve your goals. But with 1,000 images, where each class is having only 400 to 500 images, there is no way we can build a deep learning neural network that will solve our problems. Make sense, Sarvanan?
If you, sir, if you see, this is the issue I'm getting. Yes, sir.
Yeah.
If you see, this is the issue I'm getting. I'm passing the test image generator, and
Ah.
I'm predicting the data, but everything is giving a same value. If you see, it's everything looks similar values, and that is the issue. I don't know what else to proceed with it.
Yeah,
Even if you go under here, it also giving the same value.
because with 200 300 images, your neural network is not able to extract the information required to identify it as a bicycle, boat, or a cat. What you can do in the same code, I gave you the cat class, right? Cat images. You can put around
Yes.
20,000 cat images in this, and you can see the difference.
Okay, sir. Let me check on. Like
Hmm?
if you see, this is
Ah,
another. This is the same one.
ah.
It has a different CSV file. It is already classified. Is there any way we can match both of these? This is an CSV file which contains the path and the name in which class it belongs to. Is
Ah.
there a way we can merge those both, so it may be able to get a better understanding? The model can be better understanding, right? If you see motorbike, if this name comes means in motorbike, it's already classified. So only, sir.
So this is only the classification output which you have, correct? Here.
Yeah, it's already classified. With this, we
Classified.
can generate it, right? Yeah, because
No, with
model doesn't know.
ah,
Yeah,
tell me.
because model doesn't know. It's we are just making us generating. We are using an image generator model to generate or form an indices, whether it is boat or a cat or something. But it is already been given as motorbike. If it comes under this image, it is already been classified already. With this, whether we can merge those both and able to generate, that's what my question is.
So here, uh, when you say you want to merge this with your other example of images,
Yeah, totally. They
you
are
will have
both are same examples.
ah,
These are, if you see, these are both the same examples. These are the labels which I got, and these are the images which I got. So that's what it would be better to train the images. It would be feasible. It is more efficient to train the images alone than it will be better efficient, right? If you train along with the labels. So that's what I'm thinking. So only I asked if anything we can do. We can train with the labels, so it might understand if this comes under this. So only, sir. Yes.
yeah. So and show me the other example where you have put the images input, the
Yeah.
other code.
Similarly, these are both the same code, like the same one, but I just splitted it. I didn't want to confuse those two. So I just
Okay.
started with the only flow directory image generator. I tried it. Then I haven't gone through this one. I have to search. That's what I asked. Anything can be done.
Go up a little bit. Go into the params. Go into the params. The summary network that is getting created. So this has about 9,000 and go down further. Now go down, further down. Click on add a new row here. and click on train image gen. Dot. Yeah, okay, let it run.
Sorry. Yeah, dot.
Go down further. This is directly generating the images from the folder that you have kept.
Yeah.
Okay.
It's like it's indexing the images. It has separate folders. It's going through and labeling with the if the image comes from that folder, it is labeling as cat or motorcycle like that.
In fact, the same example, you go to go to collab in my directory. Okay, here, 1 second. Click on that image generator. Yeah, that one. Open that file and right click and open this.
Yes.
Run anyway. Yeah. Now you see uh, this particular folder. Okay. It has 25,000 images that we are trying to train total. Okay.
Yes, sir.
If you go to that URL, you can download 25,000 images of cats and dogs only, which you want to use as classification. Now you look the amount of images they have given, right?
Okay.
It is 25,000. And what we were doing, we are taking only 1,000 images, 500 for the cat and dogs, correct? Only 1,000, which is
Yes, sir.
similar to your problem, correct?
Yeah.
And here, when we are trying to train, our model is not giving you good performance because we just have about roughly 2,000 images.
Yes, sir.
So what we are doing, because the amount of images are very less, we are not able to build a model. Same problem like yours, you can see in our training also it happened. It is not able to build a model that can recognize. Okay.
Yes, sir.
So with 1,000 images, 2,000 images, the accuracy will be very low. You have to start somewhere at 20,000 images for each class.
Okay, sir.
Okay.
Sir,
Yeah.
is there any way to multiply the same image? Like, is there any way to multiply the same images with this inbuilt itself?
Yes, it is there. So that is what that example was showing. If you go to the cats and dogs again, okay, you go down. Okay, so these are all 500. Total, we just have about 2,000 training images, correct? Now we
Yeah.
are building the network
Yes,
here.
sir.
Go down. Okay, here also it has the same amount of parameters which you have in your model. The layers are almost same. Now here is what we are doing. We are now generating the images. Do you see the image
Yeah.
generator? Okay, we are generating new set of images from the earlier directory.
Okay, sir.
Okay.
But I also have done the same, right? But I don't know what is this wrong.
But your thing for each class, it is showing only 400 images.
Yeah.
1 minute. Hold on.
I think you're talking about where we are rotating each image into 4 directions,
Yeah.
so to increase the
Yes.
data.
Yeah, that's what I'm talking about. Can
Okay.
we add more images through this? Like adding more number of layers, something like that.
No, layers is not the answer. Adding
Sorry,
more.
not
Uh,
image generators. I'm saying.
yeah,
Is
you
there any
can
way you
add.
can add more image?
Yeah, you can add more images. That is what we are doing here. It has found 1,440 image. No, Yeah, here. No, the earlier example which I showed you there.
Yeah. So even though when I tried to run, the accuracy just started around like below 1%. Sorry, 10%. So that is what bugging me. The maximum I got the accuracy is over 20%. So only I reach out. I've been trying this from the night.
Go up a little bit. Do one thing. You can copy there is this cat's images, right?
Yes, sir.
You just copy about 3,000-4,000 cats images and put it into that folder. Others you remove.
Okay.
Comment out all other classes. You can probably add only cats and dogs.
Okay.
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 Add only the cats and dogs, and see with 3,000 to 4,000 images if your cats and dogs accuracy is improving it or not.
Okay.
Okay. You will come to know the difference that happens when you are adding only 400 images of one class. So in your example for cat, you are having 400 images. You increase the number of images to 4,000 and then see if the accuracy is improving or not.
Okay.
Okay. Then you send me an email if it is working or not. Okay.
Yeah. Okay, sir.
Yeah.
Sure.
Yeah. So welcome.
And that's
We
it.
have, yeah, we have Sarvanan and we have Swati, Smita, Satish, Sarvanan, Preeti, Jaideep, Bhupender, and Bharat. So what Sarvanan was asking was that he has created 4 classes that he wants to identify, and for each class he had 400 images each. Now when you are having only 400 images each, he is also observed that when he is training, the accuracy is not increasing beyond 10 to 20%. So 400 images is too less an image size to work with. In fact, minimum, if you're doing a good modeling, we should start with somewhere around at least 20,000 images for each class if we have to build a good model. So deep neural networks, CNN or any neural network, these are all data intensive training models. And if you need to work on this, then image generation becomes a very important part of this whole activity. And that is where last time also we saw example of image generation using data labeling, annotation. All of these are different ways of generating the images. Yesterday, okay, yesterday what we did, we built a model that was for a bike sharing company that gave information about given certain uh, let me just share my screen 1 minute. Given certain temperature and given certain temperature, humidity and related information, it had to give us the count of the number of bikes that will be on the streets. That is what we were trying to do yesterday. And then we had to deploy that model. So the model that we were trying to deploy was using Flask framework. So we will be continuing with that example. So I'll just recap and do what we did yesterday a little bit, and then we will continue. So give me 1 minute. I'm just opening the files. So one of the things which uh, I just wanted to show you is when you open Anaconda, it is a good idea to run the Anaconda as an administrator. Like I told you yesterday, many of the files don't work if you are running it as a user. So you need to run it as an administrator. So yes, Preeti, you have a question for me? So it is just opening up the Anaconda navigator.
I just have a quick question. In our
Yes,
in cat dog detection, we used image augmentation to increase the data.
right.
But the generator that we created over there, it's not being passed along to any model, unless I'm missing something. Because the generator that is there in the code,
Huh.
it is just being used by Matplotlib to show four variants of an image.
1 second. I'll just open the collab.
I'm my bad. It's the same parameters are being sent to other image generators, so they are doing the flipping of the image and resizing.
They're doing it right.
Yeah. So then Sarvanan's issue where he just had 400 images, that should have been sorted, right, with this, because the number of
He may not have added the complete code into it.
okay.
He has to add these pieces of code, no? Shift the range, wide, shear,
Right.
all of this.
I had it, sir.
You added
I added those. Yeah, I added those.
even these
Rotation.
of code I can see on my screen.
This is the part which is just showing an example of the augmentation. The parameters which we are passing just one cell above are being passed to
Yeah,
all
it's
other
showing
generators.
how much times it's generating like that. It's showing just for one image.
So from here we are picking up the files from the directory, all of them. Okay, and below
So the very first generator also has the same rotate range, shift, and everything. Same parameters.
yes, here we are resizing it. So the first time so this is the train generator flow that is generating the data in the directory, augmenting the data. So this is where we are augmenting it. Earlier one we were not augmenting it here. And here one more thing which you can add. Do you see here dropout? Did you try adding dropout to your layer?
Yes, sir. Dropout, patch normalization, everything.
You have added all of this dropout also.
Yeah. Yes, sir.
In fact, what you can do is you can replace your files with the same code that we have. You can put two images of 200, 300 and see how it works in this piece of code.
Okay, sir. I'll try.
It is the same thing. And you see if the image data generator is making a difference or not.
Okay, sir.
Okay, it should make a difference. So yesterday we had launched the till yesterday we created the pickle file, right? That is the serialization file. And today we want to use the file for creating a website that will generate the model. So we ran this file. And what we'll do now is we need to build a website. To build a website, we are using PyCharm. I'm showing it to you from the beginning. You can all see my screen. We are opening PyCharm. I'm just going to explain you how Flask works. Okay, give me a minute. Just going to explain how Flask is working. And then we'll open up the Flask code. So what is Flask framework? So Flask is a framework that you will use for creating websites. And there are many other frameworks which are available that enable you to create websites, but Flask has better support for ML models. You can also use Django, you can use Node.js, okay, all of this. Now here, how does it work? So what happens is, how does Flask work? So we have the one minute, I'm just not able to connect my enable editing. So what we have here is, this is a Flask framework. The user, we create a HTML page with the form, okay? And in this form, the values are entered. We have a .python file. The .python file runs on the Flask server, and this Flask server will process the data that are submitted through the form, processes and send the output back to the user. This is how typically it works. We use a server called as G-Unicorn, okay, and that server works along with the Fast framework to process the Python and HTML pages that are coming in and sends back the results. So how does Flask work? So we use the Flask import framework. There is a app page. The app page, whenever any user visits the URL, then the app page is activated, and then the moment the this is the decorator, it is informing that this app, that whenever a user clicks on, for example, ebay.com, this is a website, then this function should get activated. So the moment the user hits ebay.com, it will that is the home page. Then at that time, this particular function hello works, and it will return a message hello world on the browser. So these app root colon, these are known as decorator. What the app dot root is telling, this is the first page from where it should get activated. Okay, so there are many other frameworks. There is a Django framework which is more advanced than Flask. So Django is used for building complex websites, whereas Flask is used for building medium-sized websites, and it is also useful for building REST APIs. Now, what are REST APIs? REST APIs are application programming interfaces. They are called as REST APIs, application programming interfaces. Now, what does this mean? Whenever you build a model, you want to expose that model as a URL. Okay, that URL is called as an API. So you can, why do we expose it as an API? Like, for example, if somebody has to, you built a fraud analytics model, for example, okay, you built a fraud analytics model, and if anybody, and what that model does is, if you give information of the name of the user, age of the user, and income of the user, okay, you give these parameters to this fraud model, it will tell us, whether the transaction, so you also pass the transaction information, and when you pass this transaction information to the fraud model, it will give us a answer in Y or in yes or no, to tell whether the transaction has been fraud or not. So when you have to, when you create a model, how do you tell other users to use your model? There are two ways to tell other users to use your model. One way is you give away your code, okay, to them, and tell them, okay, you use the application the way you want. Another way is you don't give away the code, you rather expose them like an API. So the typical URL of an HTTP API will be http colon the name of your bank, for example, hdfcbank.com/fraud. Okay, this is the URL. So whenever any user wants to do fraud detection, he will pass the information through the URL. Like, for example, how do you pass information through the URL? So you, many times on the browser, you will see it is written as SDFC, http colon hdfc.com, okay, .com question equal to, okay, or you put a question mark equal to, and in this URL only you pass the information that the fraud model needs. Like, that is, you pass name equal to Ajay, age, income tax. Like that, you build an URL and pass the information through the browser to the URL, and then the URL will give us a return answer. So that is how APIs work. When you build APIs, it is far more flexible in the sense that you can share your code with multiple users. If and also you can build in authentication into that user, which means unauthorized people cannot have access to that API. Only people who have the subscription, or whom you will allow, will only be able to access that URL, and they will get a result. So this is how models are deployed. So we will now see an example of model deployment. Give me 1 minute. Okay, so here you can see on my screen last yesterday what we did, we built a pickle file. Okay, you can see this is what the pickle file was, and I showed you the pickle file. We will be using this model, which is a serializable file, to create a website and then take inputs. So what I'm doing here is I'm going to the PyCharm community. Here I'm clicking on launch, and from here we will be launching a website. So let us go to that first. Sometimes it takes a long time to launch a website for no reason. I'm just seeing why it is not launching my PyCharm website. Just closing this now. I was having some difficulty opening the PyCharm website. I want to open it from within the Anaconda navigator, so that the default runtime that uses is the Conda runtime, and also all the packages that we need are there in the Conda runtime. So that is why I'm just reusing it. So I hope I'm able to launch the Jupyter node, the PyCharm file here. For some reason, I'm not able to launch my PyCharm from here. So let me just go here. And from here, I'm going to launch PyCharm. In spite of clicking many times, I'm not able to start PyCharm. So friends, I'll just give me a minute. I'll restart my machine and I'll be back with all of you. Just give me 2-3 minutes. Something has gone wrong. It happens sometimes. So I'll just restart my machine. I'll be back with all of you.
Okay, sir.
Yeah, sorry for this. I'll just restart. Okay, I'm back. Sorry, I was on mute. I'm again running Anaconda Navigator. I restarted my machine. Maybe because of that, it was giving trouble to me. And from here now, let me open PyCharm. Yeah, now finally it is opening. So what I'm doing here is first I'm creating a new project. You all can see on my screen, and I'm clicking on the folder path. So I have copied my project in by caps. So you can all copy it like this. Copy the by cap folder. This is the folder. I'm clicking OK. And you can see there is a virtual environment that it is trying to create. And then this is the Python base interpreter that we are trying to run. And I'm clicking on inherit and make it available to all projects. And I'm clicking on create. So it is not empty. There are already some files that are there. We will go through each of the files. I'm clicking on yes now. Now, before I show you what we are trying to run, let me just show you the output of the file that we are trying to get. So here I'm typing dir and I'm getting the list of files. Okay, so type clear. So what I'm going to do is I'm typing Python. Okay, and then I'm typing the appy file, which is my application file, and I'm pressing enter. So you can see on my screen, I just typed Python app.y file, and the Flask server has started running. Do you all see on my screen what I just did? Is it clear?
Yes.
Good. So I typed Python app.y file. Why did I type Python app.y file? So you can see here, there is a Python app.y file that I have created. This is that file. Okay. I'll explain what this file is doing step by step. But let me first show you what are we trying to do? What is the end result? So here, this website is now running on the local server. And if I click on HTTP 127.0.0.1 50 is the port number, and 127.0.0.1 is the IP address of my machine, local host. It is called as the local host. So if I click on this, I double click on it. So you can see it has opened a page. Do you all see on my screen? Okay. So till now, what we were doing was we were manually giving our input into the Jupyter file and it was giving as an output. Now here, what we'll do, we will put an output. So let us check the let us check the data file. Okay, so the bike app has a data file. So let us just open the data file here. So we have the temperature. So let us put the temperature 27, humidity 45, or it is 2.7. Humidity is 45.7 and wind speed is 21.4. Okay, and we will submit. So when we submit, it is giving us for these values the number of predicted bikes in use are 82. This is the answer we are getting. Okay, so what we did, we created a web application, and in that web application, when you are putting the input, it is giving us an output of how many bikes are in usage. Okay, so it is way off the mark. So here it is 82 while we have the actual count as 120. But nevertheless, the model itself was around was having probably a low accuracy when it is built, and that is why this answer has come. Now, how did we build this model? That is, how did we build this page? How are we getting the value 82? That is what now we will see. Okay. So I come back here and I do a Control C. So when I do a Control C, now this web page is no longer running. So if I refresh this page, or if I again go to submit, it will not work. So you can see immediately the port is closed and the website is not reachable. Why? Because we stopped the web application from running. Okay, I pressed a Control C and the web application stopped. You can see here, if you press Control C, the web application will stop and it will quit. Now, how did we build this web application? Let us understand that. Any questions anybody has so far? I hope this is clear little bit what we are trying to do. Anybody has any questions? Okay. Now, how does this file run? Okay. So yesterday, what we did was, before running the file, we had a Flask, Pandas, G-Unicorn, G-Boost, sklearn. Okay, all these are the files that are required for running this application. Now, what we are doing here is, so if you see in this application, there are three main folders. One is model. Okay, there is a libraries file. This library file has all the important packages, okay, which are required by the application or by the website. So if I click on library, there are application files. These all files are packages, like we do import scikit-learn, import pandas. All of these packages are included in this library. And then in this library, site packages, the model file that we created, okay, you can see here, bike model xzboost.pkl file. That file is there in the model folder. The scripts are sh scripts of are the basic shell scripts that that are default to this Flask framework. So it is not something that we are creating, it is already there. Then we have templates folder. So you can see this is a templates folder, and in this templates folder there is a main.html file. Now this main.html file is what is creating the HTML page for us. This is the template file. So the HTML page, you can see this is the HTML page. What is the information in the HTML page? The HTML page has information of temperature. You input the value. Okay. So here, once again, let me run this code so that you all can see what exactly was happening. So here, if you see now, we have again clicked run this Python file, and now we are clicking on the URL. So I click on the URL. It has opened a page for us. So here, if you see, what you can see is there is input values, temperature, humidity, wind speed, and submit. So how did we get this form? Now this page is getting created here in the main.html file. So if you see here, this is the user interface, which is there in templates. It's called as main.html file. In this template, we have input values, temperature. We have a name for that text box. Yes.
We're still seeing the page.
One second. Do you see here now? The code?
Yes.
Yeah. So what we did, we created an HTML page, and in that HTML page, we have written input values. This is the header, and we have temperature. In temperature, we have given a input text box. The name of that input text box is temperature. There is humidity. Okay. There is wind speed, and then we have a input button called as submit. So if you click on that input button, it will submit the values. Now, when it submitted the values, what is it doing? It is generating a URL for the for this main page. Okay, so the URL for this main is getting generated here, and it is using a post method. So the moment we submit, it is going to create an URL, and that using that URL, it is going to send information of the temperature, humidity, and wind to the page. Now let us see how the main page is working. Now, when a user, now there are two parts. One is the main.html page, where you have all the information about the page, the user interface. The second one that we have is the app.py file.
So we just selected the pickle file and it kind of generated this HTML and app file, or is it manually written before?
All of this is manually written.
Manually written. Okay.
Yeah.
Okay.
So if you want to do it, see, we can create a new project. Okay. But you know, the amount of time that will be required to create all of this will take a long time. But the file structure is the same. We can edit this. We can create a similar file for your diabetes prediction. We can create a similar format for any of your work that you are doing in your company. And if you want to generate an output, you can also upload a file that has information about your customer sales data. You can upload an Excel sheet, and you can feed in that entire Excel sheet to the pickle file, and it will give you an output. So your CEO of your company, or if there is a call center in your company, and that call center users want to know, you know, if you give these data as input about the customers, who's going to buy my insurance product. Okay. So instead of giving them a Jupyter file, you give them an user interface, and they will work through the user interface. Makes sense?
Yeah. Yes, sir.
Yeah. So here, what you can see, first, when you create a Flask page, now if I click here, file, and I want to create a new project, I can click on new and create a new project. It will create an empty folder for me. I don't want to do that. We will come to it later. Let us first understand how this file works. Now we have two files. One is the main.html, another the app.y file. Okay. Now this app.y file is going to pick up the values from this main.html file. Okay. That is how Flask framework is built. Now what this Flask framework is doing, what is this app.y file doing? You can see here. First, we are importing Flask, we are importing pickle, and we are importing pandas. Okay. These are important files that we need for our Python file. And then what we are saying is, we are loading the pickle file that we created. You can see it is there in the model folder, bike model exiboost.pickle. So here we are reading the file. Where is that file? That file is there in this folder. You can see. Okay, let me go to the folder. You can see that folder path is here. Okay, it is model/bike model exiboost.pickle. This is the name of the file, and we are loading that file into the model folder. This is one step which you are doing. Pickle is being used to reload the pre-trained model. Now the second step which we are doing, initializing Flask. Now when we are initializing Flask, what we are doing, if the website is running flask.flask name templates folder. What is the name of the templates folder? It is templates. Where you can see the templates folder, you can see here also. Right? This is the templates folder. I can rename, I can put this as user interface. Then the template folder over here will be called as user interface. Okay. Now, the one more step that we are doing, we are adding this code into the website. This is the main route. That is, whenever a user comes to your home page, he is going to hit this application. What we are saying, this is a decorator. It is saying app root. By putting a slash, you are saying the home page, and method we are saying get post. So you must have seen that in our HTML page, that is in the main.html page, here we are using a method called as post, correct? And here we are typing method get post, and you can see one more line is here. What this line says, URL for the main. So what is it doing? It is telling, it is giving an URL for the main application. Where is the main application? The main application is here. This is a function main. And on this function, what we have written, flash.get request method get. Okay, and it will render a template, that is main.html. When is this going to run? I'll do a breakpoint here. Okay, I'll put a breakpoint here, and we will again run and see. So let me do Control C, stop this from running, and then I'm again going to type Python app.y file. Now I'm going to put some breakpoints. Okay, so that you know how the page is getting loaded. Okay, so here I have put the breakpoints, and now from my run, let me run this file. So app, it is, we will do in debug mode. Interpreter will be debug. So the page has still not run. It is first come to this location. It has to load the pickle file. So what I'm going to do is, so I'm typing Control Shift F10. So you can see on my screen, this is step in, step over, step into. Okay, so these are the different things. Now we will run it from here. Step into my code. So you can see the code is now running. It has loaded the pickle file. I'm again running it. I'm not able to set the breakpoints. I'm just seeing why it is not working. Okay, so I think there is something which uh, I have missed, to run it in a debug mode. I just need to see how it is run in the debug mode. Meanwhile, I'll explain this piece of code. So what we are doing here is when the user comes to this page, that is 2101. Okay, this is the page when the user comes to. So when you click on the browser and you come to this page, first it is going to hit the app.y file. So this is the root, and we are saying that uh, uh, the moment the page hits us first time, this code will get run. That is the main code, and this main code is telling run app.run. Now what is app.run? Okay, so this is the HTML. Yeah, it is saying app.run. So when you say app.run, it is going to execute the main function. Now when the main function is executed, it is saying flash.request method get and flash.request method post. So what is the method that we are using? When you click on the submit button here, you can see here, when we click on this submit button, a URL gets generated with a post method, and that URL with the post method is caught here. Because why? Because we are saying flash request dot method equal to post. A URL is getting generated that has information about the forms. So one form has the value temperature, which is here. Okay, this is temperature, humidity, and wind. That same thing is being captured on this app.y file, where we are saying flash that request.form temperature, humidity, wind speed, and the values are stored in these variables. Now, once the values are stored in these variables, we are creating a data frame with these values. So you have temperature, humidity, and wind speed, which is being stored, and it is being stored in the float format, and the value is stored in input variables. Now this is a data frame. Now what we are doing, the data frame, this data frame is passed into model.predict, and you know that input variables get the first row, And when you're passing the value into model.predict with the data frame, it is giving us a prediction called as how many number of bikes are there on the streets. That is the prediction it is making. Now, once you make the prediction, the value is stored in the prediction. What is happening is we are going to now re-render the page and return a new page. So when we return the new page, we are calling main.html page, and in that we are writing the input is temperature, humidity, and wind speed. And what is the resultant value? It is prediction. This is being passed. Now, when this flash.render template main is being passed, it is going into this templates main folder, you can see. And this was the first form. Now the second piece of code that is running is here, div class result. You can see here, in this prediction, we are passing a value to the result. Okay. Now this result value is again captured here in main. Okay. And we are saying if it is result, okay, if result is not empty, then for variable value in original input items, okay, here we are storing a variable. Now where did we get this variable value from? The variable value is coming from here. Okay, from the original input dot items. Where did we get original input dot items? So if you go here, you can see the original input values were stored in this variable, and that we are capturing over here, original input dot items. Okay, so all the values are here, and we are doing a for loop. So we are saying for variable value in original output input items, and it is generating a key value pair. So you have a key and a value, and that is getting generated, and then it is giving an output that will say for these temperature values the predicted number of bikes, and that value is stored in the result. Where we are getting the result from? We are getting the result from here in the app file. You see, this is the result. Okay. So when you say return flash render template main.html, and these values are being passed as a function to this HTML page, and in this HTML page we are printing out the final result of the page. Is this clear how the web page got generated? Any questions you have? Any doubts?
Clear.
Okay, so I'll run this file again so that you all will understand what is exactly happening. So you can see on this page, on this web app, you can see I'm typing Python and .app.y file, and I'm pressing an enter. So when I press an enter, this is the URL that is getting generated. Okay, this is the local host URL. This is local host URL means even if I give you the code, this will be your laptop's URL or your machine's URL. I click on this. When I click, a page got generated. What is the page? Input values, temperature, wind speed. Okay, and if you go back here, how did that page get generated? That page values came from here. Do you see on my screen? Okay, bike usage model. So let me go here. You will see this is bike usage model. Do you see? And then below it is what? Input values and temperature. So you'll see same here, input values, temperature, humidity, wind speed. So you have input values, temperature, humidity, wind speed. Now this is a form. Okay, why it is a form? Because you have a input box. That is why it is called as a form. And in this form, we are saying type is equal to number and it is an input. Okay, when you say input, this is temperature and this is input. So this is the input, this box you see. If I remove input, there will be no box that will come here. So when you put any input in this form, suppose I put 10, then the value of 10 is stored in this variable temperature. Okay, and when you click on submit, you can see this button submit. The moment you click on submit, it is going to create a URL that says form is equal to URL for main post. So where is this main? This main is here. We are generating an URL for the main page. So this is the main, and it is going to accept all get and post methods. Okay. So when we go back here and when I type on the button submit, that URL, all the values that are there in this is coming to this page. Okay. Now here in this page, what we are doing, we have already preloaded the model and stored in this model file. Okay, the model file is already stored. We are combining this app.py file with the templates file with this line of code. We are saying that this particular application should be combined with this templates folder. And then when any user comes and clicks on this page and clicks on the submit button, this line of code should get activated. So if this line of code is getting activated, we have used the post method. When is the post method generated? When I click on this submit, the post method is getting generated. So you can see this is submit. Okay, and the form action is method equal to post. Now when I'm going here and I'm directly typing, for example, I type here 127.0.1 5000. When I'm typing this, what method is getting generated? It is generating the get method. Okay, where you will see the get method. The get method is here. This is the get method. So it is generating the web page. What it is saying, if you get the get method, just return the main.html page. Where is the main.html page? This is the main.html page. So what it is showing? It is showing the input values, temperature. This form it is being showing. When you click on submit, okay, then this appy file is being called. Then this post method is now being called because we pressed on submit. The values which are there in the form is being now stored on this appy.py file. Okay, it is generating a data frame, and that data frame is passing the values to the model.predict file. Where we got this model.predict file? We got it from the pickle file here. We loaded the pickle file and stored the model, we have stored the bike prediction model in this model, and here in the model it is getting the values that were there in the form and it is making a prediction. After the prediction is made, this is the original input that it is passing. It is passing the prediction to the result. Okay, and if you go back here, after the form submit is done, it is saying the result, and it is looping through the original input items. Where is the original input items? It was here, original input items, and then it is also getting us the value of the prediction, and that is the result. This is how a Flask web page or a website is implemented, and this is how you will do it in the production. Any questions, any doubt? I can upload this file for all of you. You all can set it up and install it, because this is one activity that you can do hands-on and implement it. Is that fine, everyone? I'll upload these files on G Drive. Can you all try and do this?
Yes, yes.
Okay.
Yes, sir.
If you have any doubts, I can help you solve it. So just give me a minute. I'll upload this file to the G Drive. All of you should try and tell me if you are getting any errors. Okay, these files are getting uploaded. Just 2-3 minutes, and then you all can try running this code. How come there are so many files in this folder? This uploading of this file is going to take some time because there are plenty of files in the bike web app folder. Okay, so we can take a break. It is 4:47. Okay, we will take a 20-minute break and we'll be back after 20 minutes. So I'll just put here the stopwatch. Okay, and we'll be back after 20 minutes. Okay, so we can take a break and we will all be back after 20 minutes. By the time this file will be also uploaded and you all can start downloading the files and keep it ready. Is that fine, everyone? So it is, we'll start back at around 5:10. Is that fine, everybody? We'll start again at 5:10.
Sure, sir.
Okay. So I just put this 23 minutes. Hello, welcome back, everyone. Please try to download this folder. Please try to download this folder. ML deploy, and then run the folder, create the app, and build a web application. That is what we need to do. Can you all try doing it? Bharat, Bhupender, Jaideep, Satish.
Sure, sir.
And Smita. Okay, if you have any difficulty, ask me. If any of you is finding any difficulty, you can ask. I will show you all once again how to do is first download the application. I have already included the pickle file, so it will work for you. Or you can generate your own pickle file and then implement the code. If you are able to do with one website, you can deploy your application with any other programs also. How is it going, Jaydeep, Satish, Bhupender, Bharat? Any help you need?
No, actually, fine. Everyone was well.
Yeah, once you are done, put a message in the chat. Okay.
Yeah, actually, I'm done.
You are done?
Yeah.
Okay. What about others? Satish, Bharat, Bhupender, shall I proceed with the next topic then? If you
Yes, sir.
need help, friends, you should ask me, frankly.
Okay, actually, I want to ask a few things about two more file in the folder, like proc file and py environment file, I think.
This proc file and this on my screen, you can see this is the proc file and .cfg files, these one.
Yeah.
Okay, so these are all configuration files. They will
Okay,
get generated. Yeah, once you run it, it will get generated. Anyways, sorry.
Okay. I think we need to build these files.
Yeah, just build it once and see. And once you are all done, put a message. Okay. I'm on mute. I'm back. You all are here with me? So the thing which I want all of you to try, and I have all the stuff of this, and should be able to run the application. So if you have any issues, free to ask me. Okay, I'll help. Next topic we have to cover is NL. We will be going to higher levels. That is using sorry, my network dropped and I was continuing to talk. I apologize for that. So what I was saying was that I want all of you to run this example. If there are issues, feel free to reach out. I'll walk you through on your desktop to solve it. The next thing we are doing today is we are going to cover SPACY. We are going to cover NLP. So within NLP, we are having two frameworks. One is the NLTK one, another one is SPACY. This is what we are going to cover. So one question I want to ask all of you is, where did we use NLP in our project? Do you remember any projects that we have used? NLP? Naive Bayes, very good. Where else did we use? At least some portions of text mining, NLP, which you all remember that we have used. Anyone? Some areas of NLP, at least, you can tell me. The IMDb example, though, is a kind of an NLP, sentiment analysis. Do you all remember IMDb example?
Yes.
Yeah. Vectorizations, all of those were examples of NLP that we have used. Okay, so we will be building it forward in more detail. That is what I'm going to do now. So let me just pull my slide of NLP. 1 minute. So we are going to start with NLTK. You all can see my screen here. Okay, Bharat, Bhupender, Jaydeep, Satish. Okay, so there are few things which are very common in any natural language processing work which we do. So what is NLTK? NLTK is Natural Language Toolkit. Okay, it is a Python program. Okay, and it works with many natural languages. It provides user-friendly interface to data sets, and it covers over 50 corpora and lexical resources such as WordNet. Okay, the library can do different operations such as tokenizing, stemming, classification, parsing, tagging, semantic reasoning. Okay, this is what these are the different things NLTK does. So we will be understanding what are the basics of NLP, what is tokenizing, what is stemming, okay, and how we will implement it in a text mining or in a text classification problem. Okay, that is what we are going to look at. So where all we can use NLP, we can use it in sentiment analysis, chatbot, speech recognition, machine translation. Okay, all of these areas we can use natural language processing, spell checking, information extraction, websites, keyword search, advertising matching. Okay, and also one of the problem statements that Jaideep had given, where he had a bunch of PDF files and he needs to extract the PDF files and then label those files. Okay, that is what. So these examples that are there will help you, Jaideep, in understanding how to implement it. Makes sense, everyone?
Yes.
Okay. So when you look at there is two things. One is natural language understanding. Another is natural language generation. Okay. Suppose you want to generate a essay, or nowadays, people are generating content in an artificially intelligent way. So all these areas NLP comes in. Text planning, sentence planning, text realization, okay, natural language understanding, mapping inputs to useful representations, all of this come under that. Now, what are the problems in natural language understanding? One is lexical ambiguity, synthetic ambiguity, and referential ambiguity. We'll try and understand what kind of ambiguities these are. So you can see here, she is looking for a match. Okay, what does it mean from a lexical standpoint? You can also say if she is in a kitchen, okay, she is looking for a match means she is looking for a matchstick, jalane ke liye matchstick. Makes sense? If she is a young teenager, then it means she is looking for a match, means a marriage match. तो दो मीनिंग हो गया इस सेंटेंस को. करेक्ट? समझ में आ गया आपको लेक्सिकल एम्बिग्यूटी यहाँ पे?
Yes, sir.
When you say she is looking for a match, it could mean a matchstick also, right? एक matchstick जो जलाने के लिए यूज करते हैं. Okay, so this is a match. Another meaning of this could be a matrimonial match. Okay, these are two match. Abhi fish, another example. Fisherman went to a bank. Abhi a went to a bank can be a river bank. Correct? River का जो sides है उसको bank बोलते हैं. So he went to a river bank for fishing. Another meaning of this can be he went to a bank for financial transactions. Correct? तो इधर lexical ambiguity आ गया. Does it make sense, everyone?
Yes.
Yeah. Now, synthetic ambiguity. Okay. So synthetic. The chicken is ready to eat. Now, this means the guest who's come, for him the chicken is ready to eat. It can also mean the hen or the chicken is ready to eat. Make sense? एक ही सेंटेंस. दूसरा, विजिटिंग रिलेटिव्स कैन बी बोरिंग. ओके, अभी इसका मीनिंग देखो. अगर आप कोई रिलेटिव, इफ यू आर विजिटिंग एनी रिलेटिव, then that process of visiting the relative can be boring. Another way of looking at it is the relative who has visited you can be boring. Does it make sense? Another thing here. I saw a man with binoculars. What does it mean? You have taken a binoculars and through that binoculars you saw a man. That is the meaning of this sentence. Correct? One meaning. Another meaning is you saw a man who had binoculars in his hand. Make sense? Does it give you two meanings for this sentence? I saw a man with binoculars. It means आपने जब when you took binoculars in your face and you are seeing a man. Another way of reading this is you saw a man who had binoculars in his hand.
Yes, sir.
Okay, two meanings. So that is synthetic ambiguity. Referential. The boy told his father that the boy told his father about the theft. He was very upset. Now there is a problem here. Now this he, does it refer to father or the he is referring to the boy? Referential ambiguity. So these are the different problems that are there anyway in natural language processing, which are quite difficult to solve. Now, how do we generally very difficult to overcome when these problems are not there, when there are some specific statements, then what we are doing is we are trying to use these different techniques to do natural language processing. So you all remember we did tokenization. Can you tell me what we did in tokenization? Any example you can tell me how tokenization was implemented by us? Any one of you in 2 lines, can you tell me?
And splitting the sentence into different columns based on the frequency.
Very good. So if an entire, if you had 50,000 reviews, okay, what we did is we took that 50,000 reviews. First, we counted the number of words. Okay, we arranged it in terms of frequency of the words, and for each word with the highest frequency, we started with an index 0, 1, 2, 3, and like that we built a dictionary that had key value pairs. On one side we had the word, another side we had the index. Makes sense, right? That is how we did tokenization. Agreed?
Yes.
So now let us see more different ways of natural language processing. One is stemming, lemmatization, parts of speech, named entity recognition, and chunking. So these are different more techniques that will help us improve our natural language processing. So tokenization, you all see, we did 2 big examples. One in naive Bayes, another we did with the IMDb database. Okay, so we know how tokenization is implemented. So you break down complex sentences into words, understand the importance of each word with respect to the sentence, produce a structural description of the input sentence. Okay, so here what you have is tokenization is the first step in NLP. We already did that. So tokenization is the first step in NLP. You are breaking down all the complex sentences into words, and then we implemented different types of tokenizations. So we did n-gram, we didn't do bigram, we didn't do trigram. So what is n-gram? Anyone can tell me? N-gram method of tokenization.
One word at a time.
So yesterday in IMDb database, you saw we used one word, okay, the, and. So all this is n-gram ways of tokenization, okay. Now, if you are going to build tokens using two words, then it is called as bigram, okay. Like for example, who is, what are, okay. Whenever you use combination of words, okay, first you generate n-gram, then you go ahead and generate a dictionary with two words that are appearing consequently. Then you build a dictionary with 3 words, okay, that are occurring consequently. All these are different methods of generating the vectorization or tokenization. So you generate tokens with 2 words, you generate tokens with 3 words, and with 1 word. So these are more advanced ways of building tokens. Now, what is stemming? Okay, stemming is a process by which you normalize words into a base form, or you create a root form of the word. Like for example, let us think of missing. Okay, what is the root for missing? Miss, right? So you have missing, missed. Okay, so these are 2 words. The root for missing is miss. Now here you can see, in this particular case, the root word is affects. Okay, one second. Give me 1 minute. Yeah, you all can see my screen. Okay, visible. So here the root word is affects, and from this we are generating affection, affectation, affections, affected, okay, affection, affecting. These are all different words, but they all are coming from one root word. Okay, so the word is affect. Now this process of generating the root word is called as stemming. Lemmatization, group together different inflected forms of words, is called as lemma. Okay, like for example, somehow similar to stemming, as it maps several words into one common root word, the output of lemmatization is a proper word. Like for example, here the lemmatizer should map gone, going to go. So this process is called as lemmatization. Because you can see, this is go, and gone and going are completely different formats of the word. So that is why it is called as lemmatization. Now stop words. Many times in your entire text data set, there are some words that really don't add any value to the sentiment. Okay, like for example, the, is, a, for, all these words, it really doesn't add meaning to a sentiment. They are just adding, they are just present there for grammatical purpose. So you can put all of these types of words into a list of stop words. So that is again another important concept you all can remember, the concept of stop words. What are stop words? Words that you do not consider as important for your sentiment analysis. 1 minute, please. So I'm back. Now we are looking at parts of speech. So here, the some of the grammatical information that you want to tag in a document is called as parts of speech. Now, coordinating junction, cardinal number, determiner, essential, there, foreign words, preposition, or subordinating conjunction, adjectives, adjective comparative, adjective superlative, list item marker, model, okay, noun, singular or mass, nouns plural, proper noun plural, predeterminer, possessive, personal. Now all of these are parts of the grammar in a sentence. So this is one type of tagging. Another way of tagging is more examples of tagging are RP, possessive pronoun, adverbs, again adverb, superlative, particle, symbol, to, interjunction, verb past tense, verb and verb past particle, verb non third person, verb third person singular, with, determiner, pronoun, possessive, adverbs. So these are the parts of speech by which you want to identify the document. So many times, like for example, if uh, in Jaydeep's case, if Jaydeep wants to identify certain documents by a particular word, then he may choose these as the identifier. It should be a noun plural or a proper noun singular, okay? Or it could be a noun singular or mass. He doesn't want to use adjectives or verbs for identification his document. He wants specific nouns that are there in the document to identify what type of a document is. So this is how we will use parts of speech in our examples for identifying the documents. So here, when you look at the sentence, the dog killed the bat. Now here, the is the determiner, dog is the noun, killed is the verb past tense, again the is the determiner, and noun is the bat. So in this way, we also identify what is the part of speech in a full sentence. Okay, so this is called as parts of speech. Another important thing which you want to do is named entity recognitions. Okay, what it means, when you have a document, okay, there are some words that will represent a movie. There are some words that will represent monetary value. There are some words that represent organization, some words that represent a person, quantities, and location. So what you want to do, whenever you are identifying these words, they should represent a named entity. It is called as NER. Like for example, if I write $10,000, okay, if I'm doing an extraction of a document, I should know this 10,000 should be my currency value, or it should be my invoice amount, or it should be my deposit, something that is related to money or monetary value. I shouldn't use this 10,000 as my invoice number. Okay, 10,000 cannot be an invoice number because it is preceded with a dollar. Does it make sense, everybody, what entity name recognition is?
It also depends on how we are doing the engram, isn't it? Like if we are selecting the currency symbol along with the number, then it becomes money. But if it's without a currency symbol, it might be some general number or other.
Correct. Absolutely. I'll show you an example. Okay, which this is just kind of a small example that I had actually showed you all earlier also. It was an OCR example. where it is useful, that is what I'm just showing you. 1 minute. So you can see on my screen, right? Okay, this is a medical document. You see? Now, when we are doing a named entity recognition here, okay, so in this example, you can see the admit date. Okay, if you see a variable that is in this format, it should generally go into the admit date column, right? If there is a 5-digit word, then it should generally go into account. Now that it all depends upon the training also. Okay. If the word is occurring as Roberts, it is assumed that it is a patient name. If you have something like this representing a number with some name of the street, then it should go in the patient address. Okay, so this part of training happens through this concept of entity recognition. Like just now, even Jaideep said, if there is some value here that is preceded by a dollar, then it should be assumed that this is a monetary value, or it is associated with the amount. It should not be invoice number. In the same way, here you can see admit type. Okay, since it is a surgery, it will always be identified as an admit type. Now all of this, how does it recognize? You will have to give him at least 10 to 20,000 files for it to recognize these kinds of entities. Makes sense, everybody? Is this clear so far, how it is used in real life?
Yeah.
So here you can see again how we implement entity recognition. You have Google CEO. Okay, so Google, it is identified as an organization. Sundar Pichai is a person. Introduce the new pixel as Minnesota. This is a city or a location. And Roy Center event, again, it is being identified as an organization. So when you are extracting data from, for example, you have about 100 files, okay, that is contract information. And a lot of people are generally doing data entry of that contract information into the database. You can run a machine learning model on that contract information. And since it is already a trained model, it will extract all of this information and generate a .csv file or an Excel file where it will have columns like organization, person or CEO, okay, location, and all the data that you want in a structured format. You can extract using packages like NLTK or SPACY that will help you extract the named entity recognition. It requires training. It is not something that you can directly start using the package and it will start working. No, that will not happen. So here, whenever you have a sentence, the sentence will be broken down into a tree structure. The sentence or phrase, you will have noun, phrase, prepositional phrase. Okay, within the noun, you have article, then noun, the verb, preposition, article, noun. This is what we saw earlier when we were seeing in parts of speech. So similarly, the syntax tree is a kind of a parts of speech representation of the sentence. Chunking, when you pick up individual pieces of information and group them into bigger pieces, they are called as chunking. Like for example, here we have we caught the Black Panther. So here you are this proposition is part of the noun pronoun. So you are creating chunks of sentences, and this whole process is called as chunking. Now, whenever we have sentences, these sentences have different meanings. They each word will have different forms. This whole type of sentence is called as inflection. And to solve these problems of inflection, we follow two methods. One is called as stemming, another one is called as lemmatization. They both are similar. Lemmatization is more advanced than stemming. So here you can see this is stemming, miss, misses, missing, missed. So for this, miss is the root word, and these are different forms of stemming, where you remove the suffix or the prefix to produce the stems. This whole process was implemented by a person called as Lancaster. Okay, he was the guy who innovated, and we will see examples of stemming as we go about. So here we have play, playing, played. This is an example of stemming. Am, are, is being represented as B. Car, cars, cars, apostrophe, these are all being represented as car. So the whole process of stemming can be the boys' cars are different colors. So the is represented as it is, the boy, car, B, different colors. So all these are proposition words. So they are being represented as B.
So can we call all these as a dimension reduction?
Kind of dimension reduction. See, the whole idea is, when you have a sentence, you want to identify the root sentence, because when you identify the root sentence, it is easy for you to associate a meaning to that root sentence and associate a sentiment to that root sentence. That is why we are actually reducing all the words which are there in a document to a root sentence, to reduce the complexity of the of counting the words, or even when we are applying different kinds of models on that, when you have different variations of the root word, it becomes difficult. So absolutely, you're right. You can call it as dimension reduction, because it is a type of data reduction, where if the document is of a very large dimension of words, you are trying to reduce it to a more meaningful document which is easy to understand, at least for the machine. That is what, as a human being, it may be difficult for you to figure out, because for a machine it is only doing computation, so or building an equation of the words. So for what you are doing using these different techniques, you are trying to simplify the process of computation for the machine.
Yes, sir. Sure. Thank you.
Yeah. So what we already learned about named entity recognition. We'll understand what SPACY is, the history, features, architecture. Okay.
So basically,
we have,
sorry.
Yeah.
So for NER, it will not combine the words. It will still be a separate, correct? I mean, in the sense, named entity, what we spoke about initially.
Yes, it
Okay.
will identify those words separately.
Separately, correct. So if we have the combination of two sentences, it will not club into one. It will be different based on the.
So here it all depends upon the on the flow of the implementation. Okay. So for example, when you are building a model, some of the basics things that you will do is vectorization and tokenization, number one, correct? Then
Right.
maybe after that you will do the process of stemming or lemmatization. Okay. Then is what you may apply a named entity recognition on top of that, or you may do the parts of speech on that. So what you're doing, you're applying different features on the entire corpus of data, and then finally you are coming up with the output. That is how it will be. Now this implementation may be different for different packages. People may have implemented it differently in different places. That we will have to see how that implementation is. But most of these, yeah,
the step at which we apply it does make huge difference.
Yes. And also, they, like for example, there are some packages that are already pre-trained. They already have done the tokenization. They have already done the stemming and all of that. You are just using it in your package. So there are different ways of implementation. In some cases, for example, when you saw the naive Bayes example, it was simple. So we were actually building the different tokenizations over there. In some cases, you may get a tokenized dictionary already. So it all depends how we are using it.
Got it. Sure. Thank you.
So now the reason why, tell me.
Nothing. I think I have missed something.
Yeah, tell me.
Let's say if there is a word bark, there is something, tree bark and a dog bark. I mean, how that word bark will be recognized in what way?
Yeah, so those are the ambiguity challenges. If you go in my earlier slide, okay.
Yes.
One second. Here I put it. Those are difficult to solve. Those challenges are difficult to solve. You see here, these are the ambiguities: lexical ambiguity, synthetic ambiguity, referential ambiguity. This is difficult to solve. Like for example, she is looking for a match. Okay.
Yes.
So it could be a match, or it could be a matrimonial match.
Yes. It is similar. Yeah, got it.
Okay. Then again, fisherman went to a bank. This bank can be a financial institution, which is a bank. It can also be a river bank.
Yes, sir.
Okay. So so these ambiguities are there. That we will have to solve it in a very different way. So some of these synthetic ambiguities, referential ambiguities, these are all complex problems to solve. But most of your NLPs, either tokenization is already implemented, stemming is implemented, lemmatization is there, NER. Some of your packages will already have this implemented. Some of them you will use these packages to implement it on your text file. That is how it is done.
Yes, sir.
Okay. So
yes.
1 minute, hold on. Before I go to SPACY, let me cover NLTK. Just give me 1 minute. I had a different slide for NLTK. 1 minute. Okay, so what I completed so far was NLTK, and what I need to do is show you an example of NLTK's implementation. Okay, so let me pull up that slide for how NLTK is implemented. 1 minute. I was just searching for the NLTK implementation. Give me 1 minute. I'm just launching that program to show you an implementation of NLTK. Just trying to load this file. 1 minute. So this is a very large implementation of a Cora problem. Okay. So what does this? It will take some time to load. I think another option for me is to run it from Colab. Let me just put it on Colab. 1 minute. Let me just copy this file onto Colab as a folder, and then we will implement it there. Okay, I'll just this has been downloaded, but it is going to hang up my machine because the data size is very large. So I will run this program on Colab. So here, what we'll do is we will implement this file. I'm uploading a training file here. This is the training file that I have, and I'll upload this training file into this Colab also. Train and the test file. So what is this? What is the problem statement? Okay, so let me open the training file. Do you all see here? Okay. So in this example, what we are trying to, this is the training file. What we are trying to do is we want to build a, question. Okay, a lot of people when they come into Quora, they will type a question that is not correct. Like for example, let me type it here. What is India's GDP? Okay, so this is a good question. But if somebody says, what a fake you are, okay, but this is a bad question. Another one is, who cares? Okay, is this a good question? No, it is a bad question. Then somebody may come up and say, what a great music you have played. Okay, somebody just has fun with Quora. Again, a bad question. So what we need to do is we need to build a model that will identify if the question is good question or a bad question. Okay, this is the business problem that we have, which we have to solve using NLP. Okay, does it make sense, everybody?
So on the last question, because we have this question mark, we labeled it as a bad question, is it?
No. See, when you are going to Quora, okay, let me take you to Quora here. Okay, on this website, Quora.
Okay.
The website is meant for asking good questions, right?
Correct. Oh, okay, okay. You are talking about
Okay.
this. Okay.
Yeah. Abhi, now suppose I come here. Okay, let me just enter. What a stupid idea. Okay, suppose I type this and I add this question. It will not allow me to add me a question.
It should basically I have a context or something. So
yeah,
okay,
yeah.
Okay, got it.
Okay, this is a tool where your question was already asked. Okay, now these are all earlier questions, but if it was a good model that was built, okay, it should stop me from asking that question on this website. Makes sense?
Yes, sir. Absolutely makes sense.
Yeah. So it is like you build a support ticket. Okay, you are having a support ticket for a bank. Somebody may just write, tell me your name. What is your name? Okay. Okay, see, you can see it is not allowing me to okay, let me try adding it. Oh, it's already allowing me. Technically, it should not allow me to ask these kind of questions.
Got it. Got it.
Right. So what we are doing is we are trying to build a model that will identify if the question that is being asked is correct or wrong. That is what we need to do. So coming back here, what is happening is on my laptop, since this data set is very large, it was running earlier, but I think there are too many applications that are there. So it is taking a longer time to run. So here we will just run this package, and then we need to load the data. So let me first load the data directly below. Okay. So here I'll go into file, click on this folder, and here let me connect to the file. Okay, so we will run the sorry, this should go up. Let me stop it. This piece of code should be up here. It should come right after this. Okay, and now I want to upload the file into my G drive. So I click here. Okay, sign in, copy, paste it into this authorization code. Okay, and in this code, we will upload a file. We have already put a file. I need to copy the part of that file here. So this is NLTK. Okay, so we'll take the training file, and I'm copying the path. You can see I'm taking this training file, copy the path, because I need to copy a new path to my training file. So I'm putting it here, and I'll put here G drive path. Okay, this is the name of the file path, and this I'll copy, and here I'm going to type G drive. This is the path of the file. Now here I'm going to run my file. I want to load the file. So you can see it has already got loaded. Okay, I'm sure you all are comfortable with these steps, right? Can I see a yes from all of you, please? This is clear, Jaydeep?
Yes.
Huh? We have done this multiple times. If you need any help, guys, you have to ask me. Huh? So now what we want to do is we want to build a model that will identify if this question that is going to ask is a right question or a wrong question. Okay, that is what we need to do. So if you see here, this is import.os, the sys file, the pandas file. We have the NLTK, the pickle file. I've just you don't need to put the pickle file here. I just added because I was trying to create a web interface for this. Then you have punct, stop words, word net, average perceptron tagger for tagging purpose. So all of these are NLP packages. Now the NLTK has a list of stop words. So what are stop words? So NLTK stop words list. Okay. So if you go here on the NLTK website, you can find a list of stop words like stop, the, to, and a. These are all list of stop words that are there within NLTK. Now, what is the next thing? The next thing is WordNet. Now, this is known as a corpa. Okay, corpa means it is a corpus of words on which NLTK has or it identifies. So NLTK WordNet. Okay, it is a type of lematizer. So you can see this is WordNet. So in this WordNet, what it does is so we are using the a package called as WordNet, and within WordNet, this lematizer, it is using the lematizer function for implementing. Now, suppose you are passing cats, cacti, geese, rocks. What it will do? It will give us an output of the root word. That is what it is doing here when we use WordNet lematizer. So it will give you different parts of speech. It will give you the tagging. It will give you various things which are available. It will give you the noun, pronoun, all of that information is what the NLTK WordNet will give us. Okay. So we are implementing the WordNet package, and this is a perceptron tagger. It will help us to tag various words. That is what these packages are doing. So we are running this package here. So once the package is downloaded, we are installing the WordNet lematizer from STEM. We are also using the parts of speech tagger. Then there is Seaborn, Matplotlib. All these are standard programs that we are using. We are using logistic regression because we want to identify if the question that is asked, is it a valid question or an invalid question. That is why for that we are using logistic regression along with NLTK. Now here we are seeing the word list. So we can see the stop list here. Let us see if we can print it out. Okay, so this is the list of stop words that we have. Okay, they really don't make any sense. So that is why we are using these stop words. Now the next thing which we are doing is in a question there are basically two lists that we have. Okay, the two lists that we are having is one is a list of question, another is a list of duplicate questions. So you want to see what is the list of so this package that is calculate the list of overlap. This we are using for comparing two questions. Are there any overlapping questions? For that, we have created this package. So it is being used down the calculate list overlap. If I use this package down, okay. So if you want to see the overlap list, if there is any sentence overlap, then we are calculating the list overlap. This will give us information if there is any overlapping in the sentences between question 1 and question 2. That is what this problem is doing here. This package is doing. So I'll run this. Now these are the list of possible tags that are there in NLTK. So this is a noun, this is a noun pronoun, a name noun. So different types of tagging which we saw in this slide earlier. Okay, you can see on my screen, these are the different types of tagging that we are using in our package. So we are using noun tags, adjective tags, adverb tags, and verb tags. So these are the tags that are present in NLTK, which we are using for our comparison purpose and for understanding the entire sentence. So when a sentence is passed into this function, it will break down the sentence. So it is using NLTK's word tokenize. It is going to tokenize the sentence. It is first going to make it into lowercase and then tokenize the sentence. The tokenized words are being passed into a pause tag. Okay, so this is the pause tag. So in this pause tag, if you pass the word John's big idea isn't all bad, okay, it is going to tag it into, it is first going to tokenize it and then tag John as noun pronoun, named nouns, then S is apostrophe, big is JJ, idea is NN, is verb. So like that, it is going to tag all the sentences that are being passed into this pause tag. Then once that is passed, we are going to use the lematize. So now lematize means you want to find the root of each of the words that are being passed in. So here we have a lemmatized word and then the class. So this tagged words that are there are passed, are first passed through the stop list. If it is not in the stop list, we are identifying it as a class and then we are lemmatizing the word. The new lemmatized words are stored in NW. Now, once the new lemmatized words are stored in NW, we are classifying each of the words as noun, adjectives, adverbs, and verbs. That is what we are doing here. Does it make sense, everyone? Is it clear so far?
Yes.
Or is it too heavy? Sarvanan, Bharat, Bhupender, Jaydeep, Sarvanan, And who
Can
else is there?
can you explain
Yeah.
limitize? What does this function does?
Lemmatization. You see here
Yeah.
in the slide, you see in the beginning, there are two types of stemming. One is lemmatization, another is called as stemming. Okay, you see here on my slide.
Correct.
Okay, see, we did not implement stemming or lemmatization in any of our examples. We are implementing it as a new thing. Why? Because we want to find more complex problems from our sentences. So stemming and lemmatization both are similar. Stemming is a simpler way. Lemmatization is more advanced way. So in which you are finding the root form of a word. So this is stemming. Okay. For all of this, what is the root word? Effect, correct?
Got it. Okay. Yeah.
Okay. Now let's go to lemmatization. Now you see here, each word can have different forms. Gone, going.
Okay. So basically, that function would consolidate everything and then make it a common word.
Correct. One common word
Kind
or
of
a
a,
unique root word. Unique
yeah,
root word.
it's kind of a replace function. Let's say, for example, if it is going, if we have four words, it kind of replace it and then make it common.
Yeah, one common word. For
One
example,
common.
if you say missed, missing, uh, miss can be I miss you, I missed you. There are different variations of that word, but they all mean the same thing, correct?
Got it. Got it. Makes sense. Thank you.
Okay.
That clarifies.
Yeah. So stemming is a simple way of finding the root. Lemmatization is a more advanced method of finding a root. Somehow similar to stemming, as it maps several words to a common word, but it is more advanced than stemming, lemmatization.
Got it. Sir.
Okay.
Yeah.
So we are implementing that lemmatization here. Okay. So first we did tokenization, correct? Then for the tokens, we are finding words, adwords, and all of this differentiator. And then we are doing lemmatization. Okay. So after doing the lemmatization, okay, this, whenever you pass any sentence into this function, it will separate out the words and give it to us like nouns, adjectives, adverbs, verbs, and tokens. That is what this function is going to do for us. Okay. Here we have one more function that is going to check the overlap between two questions. So for one question, a person is entering two types of question. Okay, so we are trying to find if there is an overlap between the question. So what we have is, if someone enters a question, we are offering him a better way of writing the question. So that is what this sentence overlap is doing for us. So here we are loading our collab, which we already did. It will run successfully. Then we are loading the data. Okay. Okay, after this is done, here what we are doing is we are splitting the data into two parts. One is the training data set. Another one is the test data set. So that is what we are doing here. We are identifying the length of the data set. We are splitting it into half, and then what we are doing, the first half is called as the uh, training set, and then the second half of the data set is called as the verification data set. That is what we are doing here. So what we are doing here, we have generated the grammar for our text. Okay, so if we go here up TRX, my just give me a minute. It is just hanging up. Just give me a minute. Some function is running. Yes. So so here what we are doing is we are passing the data frame, and within the data frame we are storing it into a uh, uh, we are creating an empty. My collab is just hanging up. 1 minute. Let me just close all of this. So now it should work. So here we are creating an empty data frame, and then we are separating out the adjectives, the adverbs, okay, nouns from the from this data set that we have. So it is generating a list of grammar for each of the data set and storing it into a data frame. So the same process is being applied for verification data, where it has to generate the grammar for the data set. This is what we are doing here. So let us give it a few minutes. I'll explain the code below while this is running. Now, once this is run, we are going to find the correlation between the grammar, that is the noun, verbs, adjectives, all of this between the two questions. So One is the right question, another is the wrong question, and some questions are duplicate questions. So we want to find the correlation that is there between these two type of questions. So that process is happening here. So let's give it a few minutes, and then we will move ahead. Just give me a minute. We will give it a few minutes. Let this process get completed. Yes, Monica, please tell me. Yes, yes. Thank you. So here, first, in this process that we have, we are generating the grammar for the training set, and then similarly we will be generating the grammar for our verification set. Okay, after this training and verification set is completed, we are going to find the correlation using this grammar noun, pronoun, all of this information between the questions within the between the two columns. Okay, so we have two columns of data. One is the regular question, another is the duplicate question, and then the wrong question. So here we are going to find the correlation, and once we find the correlation, what we are doing is we are using logistic regression to train the values. Okay, so in TRX we have the trained values, and in DF duplicate we have the duplicate sentences, and then here when you pass the verification values, okay, it will tell us whether the question that is being asked is a duplicate question or not a duplicate question. So that is what this model is doing over here. So I think we'll have to complete. So this is completed. We will just run the verification. Okay, you all are with me. There is a correction, okay, with what we were doing. This problem statement is helping us identify duplicate questions. Okay, that was the that is what this package is doing. So here, if you see in the data set, there was one more example which was there on Quora in the Kaggle. I thought I downloaded that example, but here in this particular example, what we are trying to do is if there is a duplicate question that is asked on Quora, it should identify that it is a duplicate question. So that is what this is doing. So here, if you see, should I buy a Tiago? So this is being identified as a duplicate question. Okay, all the zeros that are there, they are representing duplicate question. Okay, so here, what is the step-by-step guide to invest in share market in India? Again, what is the step-by-step guide to invest in share market? Now, this is not a duplicate question. What is the story of Kohinoor diamond? What would happen if Indian government stole Kohinoor diamond back? So these are not duplicate questions, but wherever one is given, these are duplicate questions. I am a Capricorn, sun, cap, moon, cap rising. What does it say about me? I am a triple Capricorn, sun, moon, ascendant in Capricorn. What does it say about me? So in this way, though the sentence is put in a different form, they happen to be duplicate questions. So wherever it is written as 0, they are non-duplicate questions, and wherever there is a 1, it is a duplicate question. So what we need to do is, in this, identify a model for identifying duplicate questions. So here, the processing for training is completed, and what we are doing is now we are trying to find the correlation between the data of duplicate values and non-duplicate values. So here, why isn't this running? This is completed. So I'm getting a not a number error here. It could most probably because this is most probably happening because I uploaded a wrong file here. Let me upload this file too, because what I had done to make this file run, you can see on my screen, all of you, to make this file run on my local, I had deleted some files from this train. I had made it very small. The original file is supposed to be 61 MB. I had reduced it to 2 MB so that I could run this file. What I'll do is I will upload the original file here. I'll upload this train2.csv and delete this file. And here I'll put it as train2.csv and then run all. This should work. So this is taking more time than expected because the amount of data that is there is huge. What I'll do is I'll just explain, and then later on you all can run it. We can again discuss this tomorrow, next week. That is this NLTK problem of identifying duplicate questions. So what we are doing here is the training set is prepared. Now the next one, from the training set, we are separating out for each sentence the adjectives, the adverbs, and all the different words which are there in a sentence. We are separating it out in the training set. And then here we are doing the same with the verification data set also. We are separating out the nouns, verbs, adjectives, adverbs. And once that is separated, we are comparing the correlation between the we are finding the Pearson correlation. So we are using the Pearson package, and in this Pearson package we are finding the correlation between a sentence which is duplicate. Okay, we are extracting a sentence which is duplicate, and we are also extracting the adverbs, verbs which are there in a sentence, and then we are finding the correlation between those sentences. So it will give us an output of the correlation between how NLTK sees if a sentence is correlated, and how we are saying if a sentence is correlated. So this program has to run, and finally when that is done, we are building a logistic regression model. In this logistic regression model, we are passing the words, adverbs, all of that which is there in this TRX values, and then we are also passing the label whether it is a duplicate question or not. And then we are making a logistic regression model, and we are using this logistic regression model to predict if a sentence is duplicate or not. So here you can see we are passing the validation text in this particular model, and then this model is going to tell us whether that sentence is duplicate or not. So we need to run this entire program to see how well our logistic regression has been able to predict if a sentence is duplicate or not. So what we did here is we have used NLTK to separate out all our sentences, and then we are finally applying logistic regression to tell us whether a particular sentence is duplicate or not. I hope this makes sense, everyone. Any questions on this particular project that we are running? Bharat, Bhupender, Jaydeep, Sarvanan, any questions? Satish?
Nothing as of now.
Nothing as of now.
You will be able to run this, and we can discuss this more next week. Is that fine?
Yeah.
Yes, sir.
That would be better.
Yeah, we will discuss. You run all of this, and next week we'll run this example again. It's taking a little bit more time than expected. Okay. So I will end today's meeting. We will catch up next week, continuing with this NLTK, and then we will do SPACY. Okay. These two programs we will run again. So if you have any questions on the Flask or on this NLTK implementation, we will take it again next week. Thank you, everyone. I'll stop sharing and end the meeting.
Thank you. Thanks
Thank you.
everyone.
Thank you. Bye, everybody.
Happy Teachers Day, Arun.
Thank you, Satish, Bhupender, Sarvanan. Thank you.
Thank you, sir.
Thanks,
Thank you.
bye.
Bye.
the wife.